So good morning. Still try to have the group possibly because you need to have the attendance checking, right? So for your international student, move to the proper group. All right, choose one. And of course, this Monday we have the group already. That's okay. Today that's okay. Yeah. 1, 2, 3, 4, 5, and 6. Or maybe later I can put that standing page for all of you. Okay, good. It's good 5 for you. Good 5. 5 there. All right, so first of all, I think this Monday we already have two thin pair share. And I already have the answer on our line group, right? So you can check it if you still have some question, you can let me know. And if possible, I will re-explain for the possible places for you. And also for the comprehension checking for section, or maybe for chapter 3.1 to 3.3. Same, I already have the reference answer there, right? So you can check it as well. Therefore, to control the time, I skip to get back to the 3 activity there. And let me continue for a while talking about principles of reliable data transfer. And after that, then I will already have quiz number 1 here. All right, so I think all of you know we have quiz number 1 today. Well, about the reliable data transfer. If I want to send something, right now we have transport layers. So of course we care about process, sending process. So we have a process here, sending and receiving process. And of course we have a data to push to the door or the socket. Or maybe, sorry, it doesn't mean. Right now it's process, of course, it's the app layer. So we have an app. So we need to send through the door that says the socket to the transport layer. And then transport layer can take care of the reliable data transfer. Well, so here we have a reliable service. And we expect to have the reliability. And then we want to have this. We want to send, right? And actually we need to do and send to transport layer, then to network layer. However, for network layer, it's IP. IP we won't have the reliable service. So, of course, we need to have the reliable data transfer protocol. And the current protocol designed within the transport layer. And then we can ask IP to send and receive the packets so that the message can be received by the receiving process. So this is the idea of a reliable data transfer. Well, we have a protocol here. It's a transport layer protocol. So we have the complexity of reliable data transfer in the transport layer. And actually, if we have the reliable IP layer, but we don't have the reliability for IP. So if we have the reliable channel in the network, currently it's the network layer. And then reliable, so we can have the simple reliable data transfer protocol. Or otherwise, we should have the complex reliable data transfer protocol. So this one, we just want to let you know. Based on the channel is reliable or not. And then we can have the corresponding design for the reliable data transfer protocol. And of course, here we try to emphasize we have a sending side and receiving side And currently we have a curtain here, right? So that says sending side and receiving side. We don't know each other unless we have some message exchanged. And then we know, oh, what happens, for example, what happens for the sending side, and likewise, what happens for the receiving side for each other. So of course, we need to have the communication, and then each side can know the status of the other side. Right? So we try to extend. Okay, for the sending side, actually, we don't know the receiving side if we don't have any messages. Well, so we have this one to have the design. And right now, we already have something like we have the function code, reliable data transfer send. Send, of course, requested by the app layer, right? Requested by the app layer. So requested by the app layer, we have the RDT here, right? We have something like a circle. A circle here, so yeah, it's true. Send to this one, and we have the protocol. After this one, then we will send further to the unreliable channel. It's a network layer. So UDT, unreliable. So reliable, then unreliable, because network layer we won't guarantee the reliability. And for this one here, maybe you have question. Well, UDT here, but why UDT receive here? Anything wrong? I just push you to think about this. Anything wrong? UDT and UDT. In fact, nothing wrong. Why? Because RDT within, something like within the circle. And likewise, RDT within the circle. So before entering this one, of course, you should have RDT, unless you don't have the possible service provided by the receiving side of the RDT protocol. So of course, it's true. You see, RDT, before this one, then we will have the function of RDT. And yes, before this one, then okay, involve RDT, then yes, we will have the output for the RDT protocol. So it's correct. But this is an entry to RDT, likewise entry to RDT. So of course, it should be RDT. It's okay? And of course, for the RDT receive, where? Here. But after that one, immediately we have RDT receive. All right. So we have the RDT send and the UDT send. And it's true, it's RDT receive. And then to RDT here, finish, so we can deliver. Deliver to the app layer. Because we recover the messages, so we can deliver. So we can deliver to the app layer. So, before we continue, I just want to mention about the current position for the function code. Is it okay? No problem, right? We need to have RDT, so of course this is the entry. And after that one, so going to the unreliable channel, so UDT send. Of course, this is a UDT receive, but we don't indicate UDT receive. But after that one, immediately we have RDT receive to involve RDT, reliable data transfer, maybe sub-procedure. And after that one, get the data so we can deliver the message to the receiving process. So the positions here, they are exact, no problem. Even you think, okay, we don't have the symmetric property. Yeah, no, because we should have the proper entry to the functions. Well, so this is RDT. And right now, we want to have the further studies. So of course, we should get started. So we want to use the incremental manner. So incrementally develop the sender and receiver sides of the RDT protocol. We have the receiving side and the sending side. For each side, we should have the corresponding protocol to have the action, to have the stat, to have the others. And of course, we can consider unidirectional data transfer. Oh, bidirectional, but we try to make it simple. Sending, then we have receiving this direction. If you want to consider bidirectional RDT, you can reverse it. So we can consider the first one, the simple one, unidirectional, 单向. Unidirectional data transfer first, and then we can have the design for bidirectional. And even we pass on the unidirectional, we still can have the proper manipulation, so it doesn't matter. And how to study that one, we need to rely on the finite state machine, FSM here. Finite state machine to have the possible description for the stat and possible description for the action. You see, we have a stat within the circle, step 1, step 2. And here we have some event here, event, so that that event will cause a state transition, for example, from step 1 to step 2. And then we need to take actions. So event, action. Event within the upper position and action, the lower position. So we need to base on FSM, and later we will fully utilize FSM to have the design. And in fact, initially we base on the FSM to have the design. Later, in fact, we base on the sub-procedure to have the description. So if you have the experience of writing a program, I think later you will be familiar with that sub-procedure if you consider that way to have the description. If you want to skip the details of the finite state machine description. Well, so using the incremental manner. So first of all, this is the simplest version, 1.0. It says no big error, no losses. Well, perfect, right? Because of a perfect, so should you have the complex version? No. No complex version. So no complex version, what to do? Of course, we have FSM for sender and receiver, and for the current version, this version. That says RTT send, you just send. So make the packet, because no losses, so just make the packet. And use the resultant packet and invoke UDT send, then we can send it through the channel. Even the channel, we don't have the uncertainty, but we just receive. And once we receive, then we extract from the packet to obtain the data. Once we have the data, then we can deliver the data to the app layer, and that's all. So this is the version. This is version 1.0, the simplest one. About the simplest one, I think yes, that's it, right? And at least we emphasize this is FSM for sender, and also we have the right-hand side to have the FSM of the receiver. And currently, because of the simplest one, so we have the simplest version of FSMs, like the two versions. And finally, we emphasize it's easy, right? Even it's easy initially, of course, we use the incremental manner. So later we will have a more complex version for the different assumption. We will consider, yes, we have a packet loss, and maybe initially we have big errors, and then we have packet losses. And so that we will have the incremental version for the corresponding design. Well, that's it. So I think as I reached the point here, and that it have the attendance checking. So, well, for me. And after that one, then we have the time to have the, so wait for me. So let me switch to this. Wait a moment. So scan and respond first.
What is the duration of the quiz? How many minutes is the quiz? Like 20?
25.
25, okay. Thank you.
Duration for the quiz, that says 25 approximately, or for the remaining time for the class. So Demi Marshall, not finished. Still, you need to mention your group ID, so that's why I push you to the corresponding group. And later use black or blue ballpoint pen.
What's the number of this group?
So let me check. Anyone not finished? Finished, right? So prepare your pens. No cell phone. So, and no computer, laptop. Just your pen, black or blue. So let me measure. Are you ready? Okay, so let me distribute the sheets to you. Answer directly on the sheet. Three problems. Okay. Yes, yes. We have two sides, three problems.